Hey there, and welcome to The Explainer, where we break down big topics into bite-sized visual guides. Today, we're going to tackle the mathematics of uncertainty, probability.
Let's kick things off with a pretty mind-blowing idea. Probability isn't just about boring math problems, It's about understanding the chances of, well, everything, even our own existence. All right, so to really get a handle on probability, you kind of have to learn its language first. We're going to need 3 key terms in our toolkit. Okay, first up, we've got what's called a random experiment. Now, don't let the fancy name fool you. Just think of it as the action we're performing, like flipping a coin or rolling a die. So what exactly makes an experiment random to a statistician? Well, it boils down to 3 key rules. You've got to be able to repeat it under the exact same conditions. You also have to know all the possible outcomes before you even start. But here's the kicker. You can never, ever predict the actual outcome for any single try. Okay, so we've got our experiment. What's next? Well, the logical thing to do is to map out every single thing that could possibly happen. And this map of all the possibilities, that has a name. It's called the sample space. Basically, it's just the complete set of every potential outcome from our experiment. So yeah, we can get bogged down in formal definitions, but the idea is actually super simple. For a coin toss, what can happen? Heads or tails? That's your sample space. For a regular 6-sided die, well, it's every number from 1 to 6. And here you can see it written out, nice and neat. The sample space for rolling a die is just the set of numbers 1, 2, 3, 4, 5, and 6. That's it. Simple as that. All right, we've got our experiment. We've mapped out all the possibilities. So now, let's zoom in a little. Let's focus on the specific outcome we're actually interested in. And in the world of probability, that specific thing we're looking for is called an event. It's really just the result, or, a set of results that we want to measure. The formal definition can seem a little dense, but here's a really easy way to think about it. Imagine the entire universe of possibilities is this big box. That's your sample space, right? Well, the specific thing you're hoping for is just a smaller circle inside that box. That's your event. So events exist on this spectrum. At one end, you've got an impossible event, something that can never happen, like getting both heads and tails on a single coin flip. Its probability, 0, nada. Then way over on the other end, you have a certain event, something that always happens, like tomorrow being Sunday if today is Saturday. Its probability is 1, 100%, and pretty much everything else falls somewhere in between. Okay, so we've got our building blocks, right? The experiment, the sample space, and the event. Now for the fun part, we can actually put them all together to calculate the odds. Let's see how that works. And you know what? The formula is, well, it's beautifully simple. The probability of some event A is just m divided by n. Seriously, think of it like a 3-step recipe. Step 1, you count all the possible outcomes you could get. That number is your n. Step 2, you count only the outcomes you actually want, your specific event. That's your m. And for step 3, you just divide m by n. That's it. Okay, let's put this recipe to the test with a classic example. You've probably done this one before. So first things first, we need our n. In this case, it's the 6 sides of the die. Easy. Then we need our m, which is the number of sides that are even. That would be 2, 4, and 6. So that's 3 outcomes. So you take your 3, you divide it by 6, and boom, you get 0.5, or a 50% chance. See? It's really that straightforward. Okay, so why does this super simple formula matter so much? Why is it so powerful? Well, it's because this is the bedrock, the foundation for understanding chance in systems that are way, way more complex. I mean, this fundamental logic just scales right up. It doesn't matter if you're playing a game of cards with 52 different possibilities, or trying to forecast the weather with dozens of variables, or even building a complex financial model. The core principles are exactly the same. You define your sample space, you identify your event, and you calculate the odds. The numbers just get a whole lot bigger. So, if there's one thing you take away from all this, it's that probability gives us this amazing structured way to think about and actually measure the randomness of the world. It basically turns maybe into a real number. And that kind of leaves us with one last thing to chew on. If we can calculate the odds of pretty much anything, what role is really left for something like luck? Thanks for joining this explainer.